In this video, we are going to discuss the power quality of AC and DC power. Power quality refers to the cleanness of the power. For AC power quality, we want the power waveform a perfect sinusoidal wave. However, a lot of time we will get signals not perfectly sinusoidal. There's a lot of noise on the signal. We want to know how much the noise and distortion on the AC power. To do that, we first need to break down the signal using Fourier transfer. We've discussed Fourier transfer in tutorial video 1.1. You can have a good watch in that video. All these signals we called harmonics, and the sum of them we call total harmonics. These are the noise we won't get rid of. And this is the first order wave we called fundamental wave. This is a pure sinusoidal wave we want. Now we get the definition of total harmonic distortion, which is the RMS value of total harmonics divided on the RMS value of fundamental wave. So, for a perfect sinusoidal AC source, the THD is 0. Usually, it is very hard to calculate the RMS value of all harmonics. So, we use the total RMS value minus the fundamental wave to get the RMS value of the total harmonics. Both current and voltage can have harmonic distortion, so here we go. We have total harmonic distortion for current, also for voltage. The DC power quality is mainly affected by ripples. The ripple is a small signal on the DC offset. It's also the noise. We will have a lot discussion in following study. Now we only talk about one simple way to measure the DC power quality, which is the form factor. The definition of form factor is the ratio of average value of DC power divided on the RMS value of the DC power. Let's do question 6 together. In this question, it's a pure sinusoidal voltage source applied to a nonlinear load, and then we got a non-sinusoidal current, which can be expressed like this. So I will simply plot the Fourier series like this. We got a pure sinusoid voltage source, and the amplitude is 100. And we also got our current have the first order as 15, second 6, and third is 2. So the first question is ask us to calculate the power absorbed by the load. The power absorbed by load can be two parts. The first part is the DC part, because we have a DC part in the current. But we don't have DC part in voltage. This part is 0 times 8. Then we do the AC part. The AC part we do one by one. The first is 100 voltage times the 15 current. So it's 100 divided on square root of 2 times 15 divided on square root of 2. Also remember we still have angle difference, so we times cosine 30 degrees. And then we do the 6 one and the 2 one for the current. But all these two is 0. So in the end we got the power absorbed by load is 650 watts. The second question asks us to calculate the power factor of the load. The power factor is calculated by the active power divided on apparent power. And the apparent power is the RMS value of voltage times current. So we first find the RMS value of voltage is very easy, 100 divided on square root of 2. And then we find the RMS value of current is also very easy, is all these components added together. After calculation, we get the current is 14 amp. So the power factor of load is P divided on S, which is 650 divided on 70.7 times 15, and we got 0.66 as our power factor. Question 3 asks us to calculate the distortion factor of the load current. The distortion factor is defined by the RMS value of the fundamental wave divided on the RMS value. So it's easy. The fundamental RMS value is 15 divided on square root of 2 and divided on our RMS value, which calculated in question 2, is 14 amp, and we got our distortion factor is 0.76. The last question asks us to calculate the THD, total harmonic distortion. So we put all the values we've already calculated in this formula, and then we got our total harmonic distortion is 0.86. This is all about this video. We talk about the power quality of AC and DC, and we use THD to measure the power quality of AC. We use form factor to measure the power quality of DC. Thank you for watching this video. We will see you in the next video.